Okay, so we're going to be solving this question. We want us to find the nodal equation for this particular circuit and then find the voltage across the 3 ohms resistor. So the first thing is that I'm going to be using KCL because nodal equations use KCL. So basically KCL is just basically the sum of current going to a particular node is equal to the sum of current exiting that particular node. And I'm going to be representing current as V over R, the normal Ohm's law, but this one is V higher as the higher voltage minus the lower voltage all over the resistor that the current is passing. So the first thing you want to do is that you want to identify nodes. In this case, this is a node, this is a node. There's no need to register this as a node because there's a voltage source here. Let me show you as I solve, you understand what I mean by that. So this is V1, this is V2. So at node V2, V1 rather, what are the currents entering this node and what are the currents exiting this node? So surely there'll be a current that come from here. I like to think of current goes from the negative side of the battery to the positive side of the battery and then comes out powered. So the current is going to flow in this direction, and then when it reaches this V1 node, it's going to exit in this direction and in this direction. Yes. So the current for this particular place will be V higher minus V lower. In this case, V higher is what? 8 volts. 8 volts minus what is V lower? V1, because voltage will drop across these 2 ohms. So the V lower is V1 all over the 2 ohms. That's why I say this doesn't need to be registered as its own node because of this 8 volt source there. Now that's the current entering the node bar. And the current exiting the node at this point is going to simply be V1 over 4 because the node across for 4 ohms, the voltage here is V1, the voltage here is 0. At ground position, voltage is 0. Is V1 minus 0. Plus the one across the 6 ohms is simply V1 minus V2 because that's the voltages across the 6 ohms resistor. So it's going to be V1 minus V2 all over 6. That's all we have. We can simplify this equation by multiplying through with 12. We'll have 48 minus 6V2 equals to 2V1 minus 2V2 plus 3V1. Simplify, 48 equals to 11V1 minus 2V2. As simple as that. Next, at node V2, let us see what are the currents entering and what are the currents exiting. So obviously this current that's coming here will obviously enter into node V2. Now current exists at this point and at this point. So for the current entering, it's going to be V1 minus V2 over 6 equals to, so the current going to be here, V2 minus 0 over 3. And at this point, what's it going to be? It's going to be the higher voltage is going to be here because voltage will drop across the resistor. It's going to be V2 minus, write the normal minus. So then in bracket, what is the first one you see here? Minus 1 over 10. So if it was actually plus 10 minus, it will be V2 minus plus 1. So just take note of that, of the sign. So now this is going to be simply V2 plus 1. Multiply through with 30 to simplify the equation. It's going to be 5V1 minus 5V2 equals to 10V2 plus 3V2 plus 3. Simplify this, 5V1 minus 18V2 equals to 3. Now you can clearly see that this and this are simultaneous equations. You can solve this in your calculator or wherever. It's going to be V2 equals to 110 volts and V1 going to be equals to 4.56 volts. So this is 1.10. To find the voltage across the 3 ohms resistor, it's simply going to be whatever the voltage you have here minus whatever the voltage you have here. In this case, we know V2 now is 1.10 minus the voltage here will always be 0 minus 0. So V3 ohms is equals to what? 1.10 volts. This is the answer. Thank you for listening.